Chlorine Cl2 preparation properties we have to see here. Oh. Right? So chlorine is generally manufactured in the laboratory by means of reacting it with manganese dioxide. We treat it with manganese dioxide plus hydrochloric acid gives us MnCl2. ఇది లాంగ్ క్వశ్చన్ వచ్చిందండి. మీతో పాటు ఫైనల్ ఇయర్ వాళ్ళు రాశారు కదా, అప్పుడు ఇట్ వాజ్ ఆస్క్డ్ ఫర్ 8 మార్క్స్ క్వశ్చన్. MnCl2 plus Cl2 plus H2O is also formed here. Balancing you can do it. So this is how you balance the reaction. So manganese dioxide, which is a black colored powder, when you mix it to HCl, so it produces chlorine gas, right? So this is the first preparation. Second preparation is manganese dioxide when treated with sulfuric acid and sodium chloride. Here also we obtain, so the products are quite common: MnCl2, sodium hydrogen sulfate, chlorine plus H2O gases. H2O is also produced here. So this is the first preparation starting with MnO2. So one thing common है इसमें देख कर सकते, manganese dioxide plus HCl. Manganese dioxide plus NaCl gives you this one. Actually these two reactions are same. Why? Because H2SO4 plus NaCl gives you HCl and Na2SO4. Ultimately you are reacting HCl here, but here HCl is produced first, later it is reacted. That's why two reactions are given. So but the preparation is only one. Second preparation is KMnO4, potassium permanganate, reacts with HCl and produces KCl plus MnCl2 plus Cl2 plus H2O is formed. So this reaction can also be balanced. कैसे बैलेंस करेंगे? 2 लेंगे यहाँ पर 16 आएगा, I think. This would be 5, this would be 8. So this is how you balance this reaction, right? Balancing is not important, but how do you prepare it is important one, right? So this is how you should do it. KMnO4 plus HCl gives you KCl, MnCl2 plus chlorine gas. This is the second preparation. Third preparation, chlorine gas when treated with H2, it produces HCl, right? Hydrogen plus chlorine also gives you HCl. Yeah, chlorine plus H2O also gives you HCl, right? So here we use copper chloride as a catalyst. This process is known as Deacon's process. We use it as a Deacon's process. So we'll see these ones here. Chlorine was discovered in 1774 by Scheele by the action of HCl on MnO2. In 1810, Davy established its elementary nature, suggested that name chlorine is on account of greenish yellow colored gas. So these are the preparations you can see here. MnO2 plus HCl gives you MnCl2 plus Cl2. NaCl, MnO2 plus H2SO4, second preparation. However, mixture of common salt and concentrated H2SO4 used in place of HCl. HCl के जगह you can use common salt and H2SO4, where it produces again HCl, where you get the chlorine, right? So MnCl2 is formed, sodium hydrogen sulfate is formed, little amount of water is also formed here. So KMnO4 reacts with HCl and produces chlorine gas. KCl, MnCl2, H2 are other products. Here is the decons process. By oxidation of hydrogen chloride का oxidation HCl on oxidation with copper chloride gives you chlorine gas. This method is also known as decon process. ఒకసారి ఇది నీట్లో ఉన్నప్పుడు, నీట్లో లేదండి, you don't have this preparation in our NEET. Afif.
Yes, sir.
Right, if a question asked regarding this, अगर आपको ये क्वेश्चन दे के बैलेंस करने के लिए पूछ सकता है, so which is related to what? Redox reactions.
Redox, yes, sir.
Right, इस क्वेश्चन दे के बैलेंसिंग पूछ सकता है या रिडॉक्स रिएक्शन कौन सा है, ऐसे पूछेंगे, लेकिन प्रिपरेशन नीट में नहीं है. एंड नेक्स्ट प्रिपरेशन इज, दिस इज द फर्स्ट वन इज फ्रॉम द लैबोरेटरी ప్రిపరేషన్ అని మెన్షన్ చేయలేదు ఇక్కడ. ఓకే, దిస్ ఈజ్ మ్యానుఫ్యాక్చరింగ్. మ్యానుఫ్యాక్చరింగ్ మీన్స్ లార్జ్ స్కేల్ ప్రిపరేషన్ ఈజ్ నోన్ యాజ్ మ్యానుఫ్యాక్చరింగ్. Electrolysis process of sodium chloride like salts also gives you chlorine as a byproduct at anode. So these reactions are very common. Okay, so let us see some properties of it. Chemical properties of it we have to see. It is a greenish yellow gas with pungent and suffocating odor. It is about 2.5 times heavier than air. It can be liquefied easily into greenish yellow liquid which boils at 239 K. It is soluble in water. So it reacts with metals and non-metals and some compounds easily. Here reactions we have been seeing from long time, right? AlCl3 is formed when chlorine reacts with Al. NaCl is formed by the reaction of sodium and chlorine. FeCl3 is formed by the reaction of FeCl, Fe plus Cl2. फास्फोरस का रिएक्शंस भी चेक किए थे. फास्फोरस प्लस क्लोरीन गिव्स यू PCl3. अगर क्लोरीन एक्सेस में लिया है तो व्हाट इज द प्रोडक्ट यू गेट? PCl5 इज द प्रोडक्ट. Aceite plus Cl2 gives you S2Cl2. S2Cl2 डिस्प्रपोर्शनेशन हो सकता है, राइट? So chlorine also reacts with hydrogen to give hydrogen gas. H2S chlorine gives you HCl plus sulfur. Hydrocarbon plus chlorine also gives you this carbon. So these very common reactions है, आपको याद होगा. And यहाँ reactions with some compounds is very important, so we will study them easily. The first one, chlorine gas reacts with NaOH. So we have two reactions here, Cl2 plus NaOH. So first NaOH is dilute and cold, whereas this is concentrated and hot. So when your reaction is being done, the product, one of the product is different from the other, remaining products are same in these two reactions. ఫస్ట్ రియాక్షన్లో NaCl వస్తుంది, సెకండ్ రియాక్షన్లో కూడా NaCl వస్తుంది, కామనే. హియర్ యూ గెట్ NaClO, హియర్ యూ గెట్ NaClO3. So water is common in both the reaction, H2O plus H2O. Right? Where is the difference here? This is the difference here. This is the difference here. These two reactions are disproportionation reactions, right? Where chlorine is in zero oxidation state, here it is zero oxidation state, here also zero, here it is -1, here it is +1, here it is -1, here it is plus 6 minus 1 ఎంత వస్తుందండి? 5 +5 oxidation state. If you check this, chlorine has been reduced and the same chlorine has been oxidized. So this disproportionation reaction, this is the reduction of reaction, this is the oxidation of reaction. But the thing is that dilute and cold, concentrated and hot. When you take concentrated and hot, chlorine is oxidized further deeper, right? All 5 electrons are lost here. But when you use dilute and cold NaOH, only 1 electron is lost by it. So this is its oxidation reaction. Okay, so these reactions you need to study in terms of redox reactions. P block, the study of P block revises your redox reactions as well as the chemical bonding. So these points you should remember it. But anything asked on the basis of these things only. Next one, reaction with ammonia. This is another important. So ఇక్కడ కూడా అందరూ కన్ఫ్యూజ్ అవుతారు. NH3 plus Cl2. Next one, NH3 plus Cl2. So both the reactions are here. We'll go to next page. So we have NH3 plus Cl2. ఇక్కడ కూడా రెండు రియాక్షన్స్ ఉన్నాయి చూడండి. తర్వాత మర్చిపోతారు. ఇప్పుడు నేను చెప్పేది వినండి. You will able to understand it properly. Right? So ఇక్కడ కూడా 2 reactions ఏంటంటే, so first one has ammonia in excess. Second one has chlorine is in excess. Right? So do you understand the difference here? Ammonia is in excess here. Here it is chlorine is in excess. When ammonia is excess, the nitrogen will appear in both the compounds. So here you get N2 plus NH4Cl. Nitrogen gas plus ammonium chloride will be appearing. So here जो कम क्वांटिटी में है वो एक ही कंपाउंड में दिखेगा, दूसरा कंपाउंड में क्लोरीन नहीं होगा. अमोनिया ज़्यादा है इसलिए नाइट्रोजन आपको पहले कंपाउंड में भी होगा, सेकंड कंपाउंड में भी होगा. राइट. बट व्हेन क्लोरीन इज इन एक्सेस आपको क्लोरीन दोनों में दिखेगा. देख लीजिए NCl3 प्लस HCl मिलेंगे. चेक करो एक बार. क्लोरीन इज इन एक्सेस, दैट्स वाई फर्स्ट कंपाउंड में क्लोरीन है, सेकंड कंपाउंड में भी क्लोरीन है. बट व्हेन अमोनिया इज इन एक्सेस, अमोनिया लेस है, एक ही नाइट्रोजन है, इसलिए यू विल सी नाइट्रोजन इन ओनली वन कंपाउंड. इसमें नाइट्रोजन नहीं है. चेक कर सकते हैं आप. सो दिस इज हाउ इट शुड बी. ओके. So these two reactions are very very important reactions. आपको ఇక్కడ ఇది ఇచ్చి ఇక్కడ ఏ ఇస్తాడు, ఇక్కడ బి ఇస్తాడు, మ్యాచ్ ద ఫాలోయింగ్ క్వశ్చన్స్ అడగొచ్చు. కాకపోతే నీటిలో లేదండి, ఈ ఈక్వేషన్స్ కూడా నీటిలో లేవు.
Okay, sir.
Right? So if at all asked in terms of balancing can be asked. But these two reactions are there in for NEET because they are disproportionation reactions. These two reactions are disproportionation reactions. Next one, chlorine reacts with calcium hydroxide, CaOH taken twice. यहाँ पर we will get CaOCl2 is formed plus CaOCl2 is formed plus H2O is formed. So this one is, so if you check the structure of it, you got calcium connected to Cl and OCl. So this is the structure here. Chlorine oxidation number, here it is -1, here it is +1. Same element shows different oxidation numbers in this. And this compound is major product in bleaching powder. What is bleaching powder? You know bleaching powder?
Yes, sir.
Right. So bleaching powder contains this one. इसमें this part of carbon is known as, this part of chlorine is known as, this part of chlorine is known as chloro, and this chlorine with the positive one charge is known as hypochloro. Yeah, hypochlorite. So how do we write this one? Name of this compound is calcium chloro hypochlorite is the chemical name of this bleaching powder. Chemical name of bleaching powder is calcium chlorohypochlorite, right? So bleaching powder, this is another important part of this chlorine reactions. We will check this one here. With excess ammonia, chlorine gives you nitrogen and ammonium chloride. Excess ammonia लिया है, ammonium chloride plus nitrogen is formed. Whereas with excess chlorine, nitrogen trichloride is formed, which is an explosive. बम्बारी में बॉम्ब प्रिपरेशन में इसको यूज़ करते, बैंड है, right? Banned in India. This reaction you are not supposed to perform in India because this explosive NCl3 is used in the blasting material. Concentration with NaOH with dilute and cold NaOH gives you NaCl, NaOCl, right? Concentrated and hot concentrated and NaOH gives you NaCl plus NaClO3, and this is the compound here. Dry slaked lime, it gives bleaching powder. సో ఈ స్ట్రక్చర్ ఒకసారి చూస్తే ఇక్కడైనా బ్రాకెట్ పెట్టాడమ్మా, తప్పిది. యాక్చువల్లీ బ్రాకెట్ పెట్టకూడదు. ఇక్కడ ఉన్న డిఫరెన్స్ చూడండి, ఇట్లా ఇక్కడ బ్రాకెట్ పెట్టడం వల్ల హీస్ టాకింగ్ అబౌట్ దిస్ వన్, రైట్? ఓసిఎల్ అండ్ ఓసిఎల్. దిస్ ఈజ్ నాట్, దిస్ ఈజ్ కాల్షియం హైపోక్లోరైటే ఇది. But bleaching powder should contain one Cl and one ClO. It should contain this one. So we don't expect this bracket should have not been here. Okay. So गलती से दिया हुआ है इन्हें. So you should know it. Okay. Right. If you want to check, you can also check this in online. आपको मिल जाएगा. ఇక్కడ కూడా బ్రాకెట్ పెట్టి ఉన్నాడు వీడు. The composition of bleaching powder is the mixture of these 4 components. You can check here. First compound, second compound, third compound, fourth compound. Right? Calcium chloride ఉంటుంది, calcium hydroxide, calcium chlorohypochlorite. Right? We also see it in our internet में भी एक बार check करेंगे. Yeah, can you see this one here? Calcium hypochlorite is the chemical name of bleaching powder. It is an inorganic compound. The formula of hypochlorite is CaOCl2. It is vital component of commercial products called bleaching powder, chlorinating lime, chlorine powder used for water treatment as a bleaching agent. Right? इसका स्ट्रक्चर चेक करेंगे. You can also check here. Yeah, this is the bleaching powder. You see here calcium oxychloride. Yeah, this is the actual structure. ఇక్కడ కూడా బ్రాకెట్ వేసాడు, ఇక్కడ బ్రాకెట్ లేదు చూడండి. కన్ఫ్యూజ్డ్ హియర్. CaOCl2. మళ్ళీ ఇక్కడ బ్రాకెట్ వేసాడు, మళ్ళీ ఇక్కడ కూడా బ్రాకెట్ వేశారు, ఇక్కడ కూడా బ్రాకెట్ వేశారు. Okay. Chlorine reacts with hydrocarbons. इसका reactions we have seen it. Chlorine is CH4 plus Cl2 gives you CH3Cl plus HCl. So all these reactions we have seen it in the first year, right? Chlorine water on standing loses its yellow color due to the formation of HCl and hypochlorous acid. Hypochlorous acid formed gives you nascent oxygen, which is responsible for oxidizing, bleaching properties of chlorine, right? So bleaching property of chlorine is due to hypochlorous acid. Some general reactions given here. Iron sulfate is oxidized to iron sulfate 3 by chlorine gas. FeSO4. Can you see my board?
Yes, sir.
Yeah, FeSO4 plus H2SO4 plus Cl2 gives you Fe2SO4 taken thrice. Na2SO3 plus chlorine gives you Na2SO4 and HCl. SO2 plus 2H2O and Cl2 gives you H2SO4 and 2HCl. Right? SO2 is oxidized to H2SO4. Even iodine is oxidized to HiO3, where Cl2 is reduced to Cl minus. So these reactions are very common. It is a powerful bleaching agent. Bleaching color of this substance is due to this nascent oxygen. We have some uses to study about this one, right? Afif, can you read these uses?
Yes, sir.
Yeah.
It is used for bleaching wood pulp required for the manufacture of paper and rayon, bleaching cotton and textiles. Second, in the extraction of gold and platinum. Third, in the manufacture of dyes, drugs, and organic compounds such as CCl4, CHCl3, DDT, refrigerators, etc.
Refrigerants. Yeah, fourth one.
In sterilizing drinks, water, and fifth, preparation of poisonous gases such as phosgene, COCl2, tear gas, CCl3NO2, mustard gas, ClCH2, CH2, SCH2, CH2Cl.
Right. So these are the uses here. Last में कुछ poisonous gases are mentioned here. COCl2 is known as phosgene gas. Right? So carbon monoxide को రెండు chlorines attach అయి ఉంటాయి అమ్మ. Dichlorocarbonyl compound is known as phosgene gas. It's a poisonous gas. Tear gas is used by police to. So where do police use this one? If a crowd gathering को disturb करने के लिए they use tear gas, right? What do you call బాష్పవాయు అంటారు తెలుగులో గుర్తుందా? So when you pump this gas onto the crowd gathering, what will happen? Their eyes will burn and they start tearing the water, right? So this is what the tear gas is known as. Tear gas ka structure, if you check it, you have carbon with 4 bonds, 3 chlorines are connected to it. This is written as CCl3, and you have one more NO2 here. So this is nothing but nitrochloroform. Chloroform lo ee nitro place lo H untadi. This is chloroform. If this H is replaced by NO2, what do you call this? Nitrochloroform. Right? So next one is, the last one is the mustard gas. If you check the mustard gas, you have one sulfur which has 2 carbons each like this. రెండు కార్బన్లు ఉంటాయి అండ్ చివరికి ఒక క్లోరిన్ వస్తుంది చూడండి. So this is one sulfur, you have two carbons here, and the terminal one has one chlorine. So you have two carbons and terminal one is one chlorine, right? So here you have CH2, CH2, Cl, CH2, CH2, Cl, right? Dichloro, diethyl, thioether is the chemical name of mustard gas, right? So here is a question. So 7.17, write the balanced chemical reaction for reaction of Cl2 with hot and concentrated NaOH. Is this reaction disproportionation reaction and justify? Chapandi, yes, it's a disproportionation reaction. Chlorine undergoes oxidation as well as reduction. That's why we call it as a disproportionation reaction. Here the chlorine is being oxidized, here the chlorine is being reduced. So that's why it's a disproportionation reaction. Okay. So next one we'll go to hydrochloric acid, HCl preparation. Hydrochloric acid. Hydrochloric acid is prepared by Garber prepared this acid in 1648, treating with it with the common salt with concentrated sulfuric acid. Ante NaCl reacts with sulfuric acid, produces HCl plus NaHSO4 is formed. These are simple basic reactions. NaHSO4 further reacts with NaCl and gives us HCl plus Na2SO4 is formed. So ikkada 420 kelvins of temperature is used, here 800 kelvins of temperature is used. If you add both the reactions, the common things get cancelled. You get 2 moles of NaCl plus H2SO4 gives you 2 moles of HCl and Na2SO4 is being formed here. So this type of preparations is being done by this Glaber in 1648. Before the independence, he could able to produce this one. There is only one preparation. So this is the preparation here. In laboratory, it is prepared by heating sodium chloride with concentrated sulfuric acid. NaCl plus H2SO4 420 K, sodium hydrogen sulfate plus HCl gas. Sodium hydrogen sulfate plus NaCl gives you sodium sulfate plus HCl gas is produced. HCl gas can be dried by passing over sulfuric acid. Why? Because sulfuric acid cannot oxidize this Cl minus. Properties చూడండి. It is a colorless and pungent smelling gas. It is easily liquefied to colorless liquid, boiling point of 189 Kelvin, and freezes to a white crystalline solid with a freezing point of 159 K. It is extremely soluble in water and ionizes. So HCl plus H2O gives you H3O plus Cl minus. Ka of the reaction is very large, that indicates HCl is a strong acid. Its aqueous solution called hydrochloric acid, high value of dissociation constant K indicates it's a strong acid in water. It reacts with ammonia to give ammonium chloride fumes. NH4Cl fumes are generally formed when both will react with each other. Right? So ikkada inkoka point gurtupeట్టుకోవాలి ఏంటంటే aqua regia. It is 3:1 ratio of HCl and HNO3 is known as aqua regia. So when 3 parts of concentrated HCl and 1 part of concentrated HNO3 are mixed, the aqua regia is formed, which is used to dissolve the noble gases like gold and platinum. Right? So gold is dissolved, platinum is also dissolved by aqua regia. तो आपको रिएक्शन याद रखने का ज़रूरत नहीं है, लेकिन एक्वा रिजिया आपको पता करना है. हाइड्रोक्लोरिक एसिड डिकम्पोजेस salts of weak acids. Example: carbonates, bicarbonates, sulfides react with HCl and produce the respective gases. Carbon dioxide gases are produced in first two reactions and sulfur dioxide gas is produced here. So this reactions continuously takes place when hydrochloric acid reacts with it. Next we have uses, right? हाइड्रोक्लोरिक एसिड यूजेस. इट इज़ यूज्ड इन मैन्युफैक्चरिंग ऑफ क्लोरीन यूज़ करने के लिए, NH4Cl एंड ग्लूकोज प्रिपरेशन, एक्सट्रैक्टिंग द ग्लू फ्रॉम बोन्स एंड प्यूरिफाइंग द बोन ब्लैक, and in medicines as well as a laboratory reagent it is used. When HCl reacts with finely divided powder of iron, it forms ferrous chloride, not ferric chloride. Reason क्या है पूछ रहे हैं. Because यहाँ हाइड्रोजन गैस వచ్చింది కదా, the liberated hydrogen gas prevents the formation of ferric chloride. So these are the HCl preparations. Okay. Preparations, properties and uses. Next we'll see the most important one for NEET also, oxo acids. So chlorine has 4 oxo acids. One is HClO, HClO2, HClO3, HClO4. So these are the 4 acids, right? So the first one is known as, this is known as hypochlorous acid. Hypochlorous acid. This is chlorous acid. This is chloric acid. And this is perchloric acid. These are the names. We also check the oxidation numbers of chlorine. What is the oxidation number of chlorine? Madhurima cheppamma. Snigdha unnavama Snigdha?
Yes, sir.
Yeah, please can you state the oxidation numbers of chlorine in these oxo acids? Hydrogen
Yes,
the plus
sir.
1, oxygen the minus 2.
It is +1,
Yeah, here it is plus 1. What about here?
+3,
Very good.
+5,
Here it is
+7.
7. Got it? Right. Here the acidic strength, of an acid is directly proportional to its oxidation number. Right? So oxidation number of non-metal. ఇప్పుడు స్ట్రాంగెస్ట్ యాసిడ్ ఏదో చెప్పాలి మీరే. ద స్ట్రాంగెస్ట్ యాసిడ్ ఆఫ్ ఆల్ అండ్ ద వీకెస్ట్ యాసిడ్ ఆఫ్ ఆల్.
Perchloric.
Strongest acid is
Perchloric.
perchloric acid and the weakest acid is hypochlorous acid. Right? Do you relate this oxidation number to this one? आपको ऐसे कौन सा भी क्वेश्चन पूछने दीजिए, आप इसके साथ बोल सकते हो. HNO, HNO2, HNO3. Can you state which one is the strongest acid? Ikkada +5, ikkada +3, ikkada +1. So this is the strongest acid.
Yes, sir.
Yeah, any acid like H2SO3, H2SO4. So which one is strongest acid? The acid containing a non-metal in its highest state is the strongest acid. Right?
So we can apply this relation to any acid.
Yeah, you can apply to any acid. If same non-metal is present and has got more than one oxo acid, the highest one is the strongest acid.
Okay, sir.
Like in H3PO3 and H3PO4. Which one is the strongest acid? H3PO4 is the strongest acid. Okay, इसका structures चेक करना है. सबका हाइब्रिडाइजेशन एक ही है. कौन सा हाइब्रिडाइजेशन है? sp3 हाइब्रिडाइज्ड है. फर्स्ट विल सी HClO4. సో ఒక్క క్లోరిన్ ఉంటుంది, sp3 కాబట్టి 4 సిగ్మా బాండ్స్ ఉండాలి, ఒక OH ఉంటుంది అండ్ 3 డబుల్ బాండెడ్ ఆక్సిజన్స్ ఆర్ ప్రజెంట్. This is the structure of HClO4. Okay. HClO3, think about it, what you have to do? One oxygen should be removed. This oxygen can't be removed, so one of these oxygens will be removed. And chlorine has 7 electrons, correct? Since it's a 17th group element, 7 electrons are there. And it has used all 7 electrons here. 1, 2, 3, 4, 5, 6, 7 electrons are of chlorine are in use in HClO4. Right. So when it comes to HClO3, so we have to replace one of the oxygens. So double bonded oxygens अब कितना रखना चाहिए? मैं 2 ही रख सकता हूँ. यहाँ एक लोन पेयर बैठेगा. This is the lone pair here. You can also check the electrons 1, 2, 3, 4, 5, 6, 7. How many electrons are in total? 7 electrons. But how many of them are in use?
5.
Yeah, 5 are used. 2 electrons are there, so they will be kept as lone pairs. Okay, hope you understand. When it comes to HClO2, again what you have to do? You have to keep only one oxygen. This has to be removed. So that means it has chlorine and OH and 1 double bonded oxygen and 2 lone pairs. Makes sense, right? 7 electrons होना है. 1, 2, 3, 4, 5, 6, 7 electrons. All 7 electrons. Okay. So and the last one is going to be this one where you have 3 lone pairs on the chlorine. Right? HOCl has got this kind of structure. Right? ikkada pi bond ochindi kada. Ee pi bond is formed by p orbital of oxygen, d orbital of chlorine valla erpadutundi. So therefore you call them as p pi d pi pi bonds. What pi bonds are here? P pi d pi pi bonds are here. So p pi d pi pi bonds are 3 here, 2 here. Here is only 1. Here number of pi bonds are 0. Okay. Yeah, we'll see this one here. Due to high electronegativity and small size, Fluorine forms only one oxo acid, that is HOF. It is known as fluoric acid, a hypofluorous acid. The other halogens form several oxo acids. Most of them cannot be isolated in pure state. They are stable only in aqueous solutions and in the form of their salts. Oxo acids of halogens, the table is given in 7.10 and structures are given in 7.8. So here is the table. टेबल चेक कर लीजिए. टेबल में फ्लोरीन हैज़ ओनली वन ऑक्सो एसिड, that is hypofluorous acid. Chlorine has all four. ఫార్ములా నేను రాసిన ట్రయల్ వాడు ఇట్లా HOH కలిపి రాశాడు, బట్ ఇట్స్ ఓకే, ఇట్స్ ద సేమ్ థింగ్. రైట్. So HOBr is known. What is not known here? HOBr O is not known. HOIO is also not known. So these two acids are not known, remaining are very well known. So this is known as perbromic acid, perchloric acid. This is known as periodic acid. Periodic acid. Right? So the structures are also mentioned here. These are the structures. Hypochlorous acid, chlorous acid, perchloric acid, hypochlorous acid. You can also check these ones here. దీంట్లో perchloric acid లో you have 3 pi bonds, p pi d pi bonds and 1 OH group. క్లోరిక్ యాసిడ్లో ఇది ఉంది, లోన్ పేరు పెట్టడం మర్చిపోయాడు వీడు, సో ఇక్కడ ఒక లోన్ పేరు ఉంటుందండి. రైట్. సో దిస్ ఈజ్ ఇట్. క్లోరస్ యాసిడ్లో ఒక డబుల్ బాండ్ ఉంటుంది, 2 లోన్ పేర్లు ఉంటాయి. ఓకే. సో హైపోక్లోరస్ యాసిడ్లో, సో ఇన్ఫ్యాక్ట్ ఆక్సిజన్ ఈజ్ ద సెంట్రల్ ఆటమ్ విత్ 2 లోన్ పేర్స్. సో టెర్మినల్ క్లోరిన్ హ్యాస్ 3 లోన్ పేర్స్ యాజ్ యూజువల్. సో దిస్ ఈజ్ ద స్ట్రక్చర్స్. Okay. Next one is about interhalogen compounds. Did we see about interhalogen compounds on Saturday? Right. So just we have to see the preparations of it. Just we have seen the structures, right? Interhalogen compounds are 3 types, like XX dash, XX3 dash, XX dash 5, XX dash 7. X is the halogen with the larger size and X is more electropositive than X dash. The ratio between radii of X and X increases, the number of atoms per molecules increase. Thus iodine fluoride have maximum number of atoms in ratio of radii and I and F should be maximum. Why is it so? IF7 having maximum. Is it why? Its formula is IF7. Preparation చూడండి అమ్మ, సింపుల్గా ఉంటాయి, ఇలా ఏమి ఉండదు. Simple preparations are there. If you take equimolar chlorine and fluorine, we will get ClF. If chlorine is taken in excess, you will get second type. The first one is X dash type. So this is X3 dash type. Right? So ఇక్కడ ఇది 3 ఉండాలి కాబట్టి chlorine is taken in excess. Right? ఇక్కడ కూడా అదే వచ్చింది చూడండి. Fluorine is taken in excess, you get it. If you take equimolar, what do you get here? X and X dash वाला ही मिलेगा. यहाँ ICl is also this. And Br2 and F2 diluted with water gives you BrF3. If BrF5 has to be formed, so Br2 should be treated with 5 moles of BrF2. So where you get BrF5. So these are the simple preparations of these interhalogens. Right? So this is what we have seen yesterday, and few more points to be noticed here. ఇక్కడ ఇవి ఆక్సో యాసిడ్స్ కదా, వీటికి సంబంధించినటువంటి ఇంటర్ హాలోజన్స్ ఇక్కడ రాద్దాం. IF7, BRF5, BRF3, BRCl. సో ఇది హైడ్రోలైజ్ అయితే ఇది వస్తుందండి. హైడ్రాలసిస్ ఆఫ్ దిస్ గివ్స్ యూ దిస్ వన్, hydrolysis of this gives you this one, hydrolysis of this gives you this one. So hydrolysis of interhalogens gives you these oxo acids. That's what mentioned here. Preparations, and here is the properties. Just will see these properties. So these are all covalent molecules and are diamagnetic in nature. Why these are diamagnetic? Because they have halogens in even number. They are volatile solids, liquids at 298 K except ClF, which is a gas. Their physical properties are intermediate between of those constituent halogens except that their melting points are little higher than expected. Their chemical reactions can be compared with individual halogens. In general, interhalogens compounds are more reactive, point to be noticed here, more reactive than halogens except fluorine. This is because excess dash band is interhalogens is weaker than excess bond in halogens except fluorine bond. All these bonds undergo hydrolysis, giving halide ion derivatives, smaller halogen and hypohalite, halate, perhalate are anions derivatives formed here. So HX toti HOX vastundi. If you take XX3, you will get HClO3. If you take XX5, you will get XO3. If you take XX7, you will get HClO4. Their molecular structures are very interesting and which can be explained on the basis of VSEPR. The XX3 compound have T shape, whereas XX5 square pyramidal, IF7 has got pentagonal bipyramidal. So these are the structures given here. ఒక BRF5 స్ట్రక్చర్ ఇచ్చాడు చూడండి. Discuss the molecular shape of BRF5 according to VSEPR. Solution: the central BR has 7 electrons in valency shell. 3 of these will form electron pair bonds, whereas 3 fluorine atoms leaving behind fluorine electrons. Thus there is 3 bond pairs, 2 lone pairs. So these are the 3 bond pairs, these are the 2 lone pairs. According to VSEPR, will occupy corners of the trigonal bipyramidal. 2 lone pairs will occupy equatorial positions. To minimize lone pair repulsions and bond pair repulsions which are together than the bond pair repulsions. In addition, the axial fluorine atoms will be bent towards the equatorial fluorine in order to minimize lone pair repulsions. The shape would be bent, that of slightly bent T shape. Okay, so last one is the uses. These compounds can be used as non-aqueous solvents. Interhalogen compounds are very useful for chlorinating agents like ClF3, BRF3, and these are the reaction. Right? ఇక్కడ క్వశ్చన్ ఇచ్చారు చూడండి, ICl is more reactive than IF2. This point we should remember. ఇక్కడ ఏంటంటే in chlorine you have Cl bond. In ClF you have ఇక్కడ 2 హాలోజన్ల మధ్యలో ఉంది, ఇక్కడ ఉంది. కానీ విచ్ బాండ్ ఈజ్ వీకర్ బాండ్ చెప్పండి? ఇందులో ఒకటి పోలార్ బాండ్ ఉంది, ఒకటి నాన్ పోలార్ బాండ్ ఉంది. దిస్ బాండ్ ఈజ్ నాన్ పోలార్, కరెక్టే. దిస్ బాండ్ ఈజ్ పోలార్. That's why this bond is reactive, more reactive than this bond. So in interhalogens, the bond is formed between two different atoms with different sizes, different electronegativities. That's why the bond formed between two halogens is purely polar bond. That's why this reaction is very fast. Question ఎట్లా అడుగుతాడంటే చూడండి, Cl2 ప్లస్ X, ClF ప్లస్ X. సో ఇక్కడ ఒక రియాక్షన్ R1 ఇస్తాడు, ఇక్కడ ఒక రియాక్షన్ R2 ఇస్తాడు, ఇక్కడ Y వస్తుంది, ఇక్కడ Y వస్తుంది. వాట్ ఈస్ ద రిలేషన్ బిట్వీన్ R1 R2? ఏ క్వశ్చన్ పూछेंगे. Which one do you say? What is the answer for this question? What do you place here? Is it equal or is it greater than or is it less than? చెప్పమ్మా మాధురిమ, చెప్పమ్మా ఆన్సర్ చెప్పు. So ये non-polar bond है, so this R1 is slow है, this R2 is very fast. So that means here comes the less than. R2 is greater than R1. Okay.